of the Web Fundamental track. So just looking back, you learned about HTML, CSS, JavaScript, jQuery, and now it is our turn for you to learn about creating database tables. How do we create these data tables to store information that you will later be creating through your web applications? And I'll create some videos just at a high level explaining about some of the different database types there are. Mainly it breaks down to relational database or SQL databases versus NoSQL or non-relational databases. So I'll just give a very high level overview on that and give a little bit of introductions on what you will be doing. Although later when you go through the min stack, you will have more exposure into non-relational or NoSQL databases. But in this module, you're going to learn about how to create tables, how to create database diagrams called ERD, and this will be a good experience. Now, you're going to learn first how to create tables, and then you're going to learn how to write SQL queries to pull information out of those tables that you will be creating. And it may be a little bit unintuitive because you don't know how to access and retrieve records from the database table that you'll be creating. But still bear with us. Just go in and see if you can learn as much as you can from the database tables that you will be creating. And then when you get into the SQL queries, some of the things that you may have been wondering will make sense. One thing that I also want to mention is that when you're building a complex web application, you almost always create a wireframe, and then you take that wireframe to a designer who uses Photoshop or different elements to make it look nice, and then you almost always convert that to a clickable prototype, just HTML, CSS, JavaScript, or using jQuery to create the interactions. The step you do after you create that clickable prototype is almost always create the database tables. And the reason that you do that after all the clickable prototype is built is once the clickable prototype is built, everyone understands how the web application should work. And when you build a clickable prototype, in that process, someone may have some good ideas. You may want to change the clickable prototype. You may want to go through a few iterations and play with different ideas on how your website or web application could work. So by the time that the clickable prototype is done, everyone is on the same page as to what functionalities your website should have. So then, instead of going into the back end, the next step is always to create a database diagram that demonstrates how you're going to store the information that you gather on your web application and how you're going to store that in a database. So it's a good practice for you to follow. And also when you later work on your project, you will follow the same methodology. You will create a wireframe, you will create an HTML and CSS clickable prototype, and then after that, you will create your ERD. And when you're demoing your project to your potential employer or during the presentation day at the dojo, it's always a good idea to show the wireframe, clickable prototype, the ERD, before you just go in and demonstrate the backend functionality. So it's a good practice to practice how you can create ERD, and it goes very well with some of the things that you've learned in the past. So now I'll spend some time talking about kind of at a high level, what is a relational database, what is a non-relational database, SQL versus NoSQL, just at a very high level to get you started. So let's talk about SQL or relational databases and NoSQL, which is not a relational database. And this, you will have a lot of exposure as you go through the materials and see how we would create multiple tables and create a relationship from one table to the next. And again, you will have more exposure to this as you go through the curriculum. I just want to mention that there are many SQL databases out there. There's MySQL, Postgres, SQLite, Microsoft SQL Server, Oracle, there's MariaDB, and there are many Cassandra and many other databases that belong to this bucket. The good news is once you learn how to use one database and to write a SQL query for one database, that same SQL query is almost used to communicate to all of these different databases. Each database has a little bit of differences, but the SQL language itself is very common. So what you're learning right now on creating the database structure and how to write SQL query is not just only relevant to MySQL, but it can be used across all of these. Now, you can imagine, remember back early in the bootcamp, we gave you an analogy about an HTTP request and response, where we use the analogy of the IKEA store to illustrate this concept. And hopefully you remember some of the concepts that were introduced when we taught you this. We taught you how the HTTP response from the server comes back in HTML, CSS, and JavaScript in a nutshell, which the browser takes or the client takes and renders that on the browser. Now, on the server side, we talked about how the workers over here will go and get the HTTP request from the web application, and they will go to the database to retrieve some of the records. So just kind of imagine back to the IKEA store. And if you're running this IKEA store and you have millions and millions of different parts and customer information, how many ways do you think there are to organize all of that parts in your physical warehouse? Is there just one way to organize all of the inventories in IKEA store? Well, obviously not. There are many, many different ways. And one way would have some pros on maybe retrieving things faster. Maybe another way, there's more security and more data redundancy. But there are just a lot of different ways to organize different inventories in your warehouse. So you can think of this as, okay, there is one SQL query or SQL language that we use so that regardless of whether this database is organized in a MySQL way or Postgres or a SQLite, all of this can still communicate to them using a simple SQL language. So that's kind of the pros. But understand that each of these has its pros and cons. Kind of in a nutshell, one way that you can think of this is SQLite is very good for very small application. It's mainly used for testing purposes. MySQL, Postgres, MySQL SQL Server, they're all very powerful. It can probably hold up to, I would say, 100 to a few hundred gigabytes of information, maybe even a few terabytes of information. Oracle is usually for applications that handle at least 10 to 100 times of what you can store in a typical MySQL or Postgres server. And then once the information becomes way too big, let's say 5 terabytes or higher, then you need some other big data such as Hadoop to manage that database. So for most of the web applications, MySQL or Postgres is powerful enough to store all of that information. Now, most of this information is stored on disk. It's stored on your hard drive. And hard drive is big, and it's not that expensive, but it's also not as fast. So some of the database tables exist where you can create this, and it's not written on the hard drive, it's just written in memory. And memories are more expensive, but it's also a lot faster. So if you're storing some information, that is okay if you lose. You don't need to have redundancy. Even if the power goes down, that's okay, because maybe you're storing some instant messages, that is okay if it goes away. Then you can also store those things in a memory base, such as Memcache and Redis, and that will allow you to store and retrieve information, probably I would say that at least 1,000 times faster than the information that you store over here. But obviously some information you don't want to just lose if the power goes down, and therefore this is why a lot of the database is using disk-based servers. But again, later you will have some exposure to Redis and some other memory-based ways of storing information. MongoDB is a NoSQL database, and I want to spend a little bit of time just explaining what this is. And again, you will learn more of this later on as you go into the ERD. But let's just do a very quick example. So let's say that I want to store all of the user information of people who come into my IKEA store. So maybe I call it, I want to create a customer's, imagine I'm going to create a customer's cabinet. And inside the customers, I'm going to require certain fields. Let's say ID, I'm going to store the customer name, I'm going to store their email address, I want to create when when this record was created at. So the way that you can visualize this is if the customer comes over, imagine if I'm storing things in a SQL way, imagine you give them a piece of paper and say, this is what I want you to fill out. Please, well, this one I will auto increment it, so don't fill it out, but please fill out your name, and you give maybe 255 spaces where they can fill it out. Email, same thing. Hey, the line looks this long. And then create it at, you can, but maybe like, let's put description. And then hobbies. And maybe description, you're gonna make it so that instead of just, up to 255 characters, you wanna store text, which is like a lot more text than just 255 characters. Again, you will see more of what I mean later when you go into some of the diagrams. And then you wanna store hobbies, and so forth. So basically, when you do the ERD, you're outlining what fields, what information you want, and how big some of these field type needs to be, whether you're storing just a number, whether you're storing a character up to 255, and all of this is gonna matter because all the more information you have, then it's gonna you need a bigger drawer, bigger cabinet to store all of this information. So this is basically the SQL way, where I basically define, hey, this is what I need. I need name, I need email, I need description, I need hobbies. And then every single time a customer comes, you give this sheet of paper and say, can you please fill out? Can you please fill out? NoSQL way is where, and the simplest way I can explain it, again, later when you do MinStack, you will have exposure to this, is where you just give them a piece of paper where it's blank. And you basically tell them, customer, tell me whatever you want me to tell me. And then you give them an empty sheet of paper where they can just fill out. They can say, I want to give you my name. I want to give you my first name. Or they say, I'm going to give you my age. I'm going to give you my favorite hobby. So NoSQL, basically because you're just giving an empty sheet of paper, they can store whatever they want. So this is very flexible, but it also has some downsides as well. So maybe I'll put a link so they can just at a very high level understand the difference between SQL and NoSQL. But if a student, if a potential employer asks you, what's the difference between SQL and NoSQL, I hope that you can think about this illustration. And if you're thinking, do I need a SQL or a relational database, or do I want to use a NoSQL database? All you have to do is think about, well, is the information I want to capture, do I want to have a pre-filled fields that I want people to fill out, if that's the case, you want to do SQL or relational. If you're like, you know what, I'm just going to store whatever I want. And maybe I like that freedom. I can store some arrays here, some strings, or if you want that flexibility, then you can go the non-relational, this very open way. Now, this used to be very popular at some point. It kind of goes in circles. Sometimes this is really popular, and then this is really popular, and it just goes vice versa. But the downside of the NoSQL is because it gives you too much freedom, maybe some customers put their name as name, or some put it as first name, people put full name. There are so many ways that they could have stored this that sorting through all of this data could be very, very messy. So if you're using non-relational, you need more structure, and it may make the data a lot more messy, and you may have to do a lot of cleanup, which is why some companies that use a lot of NoSQL are migrating to more structured. But anyway, this analogy hopefully will give you a good idea, on when to use relational, when to use non-relational, whether you want to store things on disk, which almost all databases are, or if there are certain things that you can store in memory, which would be 1,000+ times faster. And then you can kind of think about, okay, when you do the ERD exercise, what I'm doing is I'm basically specifying what type of form I wanna fill out and store this into my cabinet. So this is basically the records, and this is basically the database schema that you're designing. But whenever I insert a record, I'm basically filling this out and I'm adding this into this cabinet. If I want to update something, then I pull out a record and then I update some information. I can select all the records here and then pull it out and display it as well. But this is just a computer way of storing information. And what you will do in this module is practice creating different database types. And then you will also create another cabinet, and you will say this cabinet is related to this cabinet by certain fields and so forth. It's a lot of fun, and you will enjoy it.